10.2 Introduction to Conics Parabolas, in particular we're looking at today, the intersection of a plane and a double napped cone, and here are some examples. Okay, so some definition, key points here. A parabola is the set of all points x, y in a plane that are equidistant from a fixed line called the directrix. So that is a line that we did not look at from an Algebra 2 perspective, at least at the regular level. I'm not positive at the accelerated level. And a fixed point called the focus, not on the line. So those are two concepts that we're going to look at today that you may or may not have learned about. The vertex, which we all are comfortable with, is the midpoint between the focus and the directrix. And I'll show you a visual in a moment. Okay? And the axis of the parabola is the line that passes through the vertex and the focus. So it's going to be important to think about, do we have a vertical axis, which would then give us like our normal parabola, right? Or do we have a horizontal axis, which would kind of be like the a y-squared parabola, the other direction, x equals y squared technically, or two square roots on top of each other is kind of the way that we've looked at it in the past. But we're going to look at it a little bit different this year. Okay, so the standard form of the equation of a parabola with vertex h comma k. So no matter what, our vertex is h comma k. Depending on where the focus point is located, that is going to be a clear go-to of whether I have a parabola that opens up with a vertical axis of symmetry or opens up with a horizontal axis of symmetry. One way to think about it is the directrix is always also on that axis of symmetry. Or, the directrix is perpendicular to the axis of symmetry. The focus point is always on that axis of symmetry as a point. So vertex and focus point are on that vertical line or horizontal line. So it's a shift. It's a distance away. So what I mean by that, if our vertex is like 0, 0, for example, and our focus point is 0, 2, that's a vertical shift up 2, right? Which means that we have a vertical line as our axis of symmetry, which means our parabola would be a y equals x squared parabola. Whereas if I had same exact vertex at 0, 0, and now a focus point has shifted to the right to 0, now I would have a parabola with a horizontal axis, and it would resemble like an x equals y squared parabola. So we're going to focus on, I didn't mean to use that word again, but we're going to take a look at where is this focus point relative to the vertex, and that can be the most helpful in determining, am I going to end up having like an x squared term or a y squared term? Both of them look exactly the same, except the x's and the y's are switched. Okay? X minus h squared equals 4p times y minus k. P can't be 0. The directrix is the line y equals k minus p. The focus, I think that's on the next set of notes, is going to be the points h comma k plus p or h plus p comma k. So that's what we'll take a look at in a moment. So here's some images for what I was just referring to. This page is good. Right? Good. So the first two examples are the parabolas as we've known them. Right? They have vertical axis of symmetries. The vertex and the focus are on that same vertical line. The directrix is perpendicular to the axis. Okay? What we're focusing on, we're looking at here is the fact that that focus from this vertex to this line, this directrix, the distances between focus to vertex, vertex to directrix are both p units. p units away, so they are equidistant, they are symmetrical about that. The focus of the first example is h comma k plus p, it's got that vertical shift. And the second example where we have the parabola opening upward, right, the focus is sort of always quote unquote inside of the parabola, right? If it opens downward, then it's below it. If it opens upward, it's above it, and the directrix is opposite. And then, so second to point out is when we have x equaling y squared parabolas, the distance is still going to be the same, right? This p units, but now the shift, p units, is a horizontal shift. Okay, so now my x coordinate changes a little bit, h plus p comma k for the focus, instead of h comma k plus p for the focus on the other one. No matter what, we're taking a look at the standard form, so we will be completing the square and things such as that. So I find it helpful to first think about the information given and think about what direction parabola do we have. And therefore, what standard form equation are we going to work with, right? And I have found that it's easiest to look at and compare vertex and focus point. Where is the shift? If you're given the directrix, you can do the same thing. Where is the shift? Or if the directrix is horizontal, the axis must be vertical, making the parabola a quote-unquote normal y equaling x squared. If the directrix is an x equals, which means it's vertical, then the axis of symmetry is horizontal, then our parabola is opening up as an x equaling y squared parabola. Okay? But that's important to kind of figure out from the beginning. Okay, so questions will be like this, as one of the examples. Find the standard equation of the parabola with a vertex at the origin and focus at 0, -2. All right, so I say to myself, the answer is given, but whatever, we're going to get there. So I say to myself, all right, my vertex at the origin is 0, 0. But I label it, especially early on. I say that's equal to h, k. Then I take a look at the focus, and I say to myself, what changed, and how do I move to get to that? So the y coordinate changed. I went down 2 units. So that's where my p value is. So this is h, k plus p, or minus p. It doesn't really matter there. In this case, I can acknowledge that it is a negative. But what I'm also acknowledging is saying that that is a vertical change, right? So if it's a vertical change, then I must have a vertical axis of symmetry, and therefore I must have my normal y equaling x squared parabola. So when I write down my standard form, I'm saying x minus h, as I've always known it, quantity squared, is equal to, this is the new part, 4p times y minus k. The 4p is different than what we've done in the past for standard form of anything. Okay, this is what's going to bring in that transition so that we have our focus identified. Okay. So now, as long as you're kind of labeling things as you go, the rest of the problem is not so tough. My h and my k are both 0. My p is the change from 0 to -2. So my p is a -2. Y minus 0. And then I can just clean that up easily. Obviously, x minus 0 is just x squared. And this is going to be a -8y. And I can leave it like that. Right, standard form does not imply that I'm solving for y now. I'm keeping it so that I could see the pattern with my h, my k, and my p. Okay? Find the standard equation of the parabola with vertex 3, 2, and focus at 1, 2. So I can start by just labeling my vertex. That will never change. That's always going to be your h, comma, k. Then I can say, well, what shifted? If I'm at 3, 2, where did I go to get to my focus? That way, right? Left, 1, 2, whatever. I went horizontal. I have a horizontal axis of rotation. I'm sorry, not axis of rotation, that's calculus. Axis of symmetry. So then I must have a sideways opening parabola. I have my x equaling y squared, which means I need that y minus k to be the side that's squared this time. So I'm going to acknowledge that h plus p, comma, k is my focus. And therefore my equation that I'm using is y minus k, quantity squared, equals 4p times x minus h. The h and the k are always associated with their respective x and y, and that doesn't change. It's really a matter of which one's being squared. So where is it? It's always something squared, quantity squared, equals 4p, the other quantity. So depending on the direction of your parabola, that parenthesis changes places. That's the only thing that changes. Right? So we're acknowledging that this time it's a horizontal shift, it's a horizontal axis. It is then going to be like a y squared scenario. And I plug everything in. So my k is 2, right? My p is how much did I change? -2 again. -2, good. Thank you over there for answering. So 4 times -2, x minus h is 3. So y minus 2, quantity squared equals -8, x minus 3.
And we don't, I guess, do anything further than that?
Nope, not in this case. If they're saying standard equation, this is what we want. 'Cause remember, well, not always. Each form of whatever function equation that we're talking about always has important stuff that we can extract. So in this sense, right, it's presented in the way where we can extract our h and our k and our p. So all of those things are key terms. So we don't want to, if we took it away from that and put it to what we know as a standard form, it's not as helpful. All right, find the standard equation of the parabola with vertex at 1, 3 and focus at 1, 5. And these instructions now say, then find an equation by solving for y. All right? So now we will take it to that next step, and there's going to be applications down the road for why we would do that. Maybe it's just purely for graphing reasons. But the same points are given, so why don't you guys give this one a try on your own? Think about which coordinate changed and what do you do with it. I'm going to pause my video while you're working. All right, so our first job is to compare our vertex, our h, comma, k, with the focus and say to ourselves, well, what changed? Was it a vertical or a horizontal change? What's the answer to that question? A vertical change, good. So that means our h is staying the same and our k is adding a p to it. So if it's a vertical change, we have a vertical axis of symmetry, we have a normal y equals x squared parabola. So I'm using the format of x minus h quantity squared equals 4p times y minus k. Right, and then we fill in our information. So we should have x minus 1 squared equals we again shifted 2, so we have an 8 times y minus 3. Oops, I dropped my 4 by accident. Oh, no, I didn't. I'm good. I did the 4 times 2 in my head. Gotcha. All right, and now since it says to solve for y, that's exactly what I'm going to do. I'm going to FOIL the left-hand side out, distribute on the right, and then isolate. So I would have an x squared minus a 2x plus a 1 equaling an 8y minus a 24. Add your 24 and divide by your 8. 1/8 quantity x squared minus 2x plus 25. If you distribute the 1/8, that's also fine. Okay. Anybody have a question on that? Alrighty. Couple more examples. So this next one gives us a parabola in true standard form for the most part, ax squared plus bx plus c. And it's saying find the focus. I know you guys have that at home, so me crossing it out doesn't do much for it, but it's out of my way. All right. How do we go about finding a focus from here? Good. Bring it back to standard form so I can pull out the information that I need. I'm going to start by pulling out an HK. Then I can acknowledge my P and do the appropriate shift, right? Okay, so I'll start by multiplying by -6. And then what skill do I need? If I add 6, I think maybe you're both on the same thing. How do I factor in the form that I want, and why are you picking 6?
You add 6 to both sides, then you have +1 or
Yeah, good. So Ellie's telling me to complete the square. And Akshay, maybe you're headed there too. Complete the square. So when I complete the square, I ignore the c that's there. When Ellie's completing the square, she's acknowledging that there's a -2 there, so in order to get the c that she wants, she's adding a 6 to get down to a 4. Okay, so for me, I would say, if I just take a look at right here, I say, well, what do I need to complete that square? That square requires a 4. So I'm going to add a 4 to both sides. That's the way that I've always looked at it. So that allows me to do one step at a time. And then, of course, I am adding that 2 to the other side, putting the 6 over there, and letting me factor this to x plus 2, quantity squared. Okay? Cool, I'm almost there. I want to take that -6 out. Y plus 1 equaling x plus 2 squared. And one more thing that I want to do so that I actually have my p would be to factor a 4 out of that -6. Right, so if I take the 4 out of that, what would I be left with? 4 times what? -3 halves. Yes, it should be. Thank you for the correction. Cool. So now I can acknowledge that my vertex is 1, -2, right? And then my focus, so I have to go in my head a little bit here and say, well, I've got technically a y equaling an x squared, as I saw before. I have an opening upward. I must have a vertical axis. I must have a vertical shift. So I take this p and I add it to my y. There's other schools of thought there, of course, but you have to acknowledge the fact that I am shifting up to get to my, up or down. I'm shifting in a vertical direction to get to my actually I'm technically shifting down to get to my focus, okay? So if I add the negative 3/2 to my negative 2, wait a minute, what did I write down wrong? I wrote the wrong thing down, didn't I? The vertex?
I think it's -2, 1.
Negative 2, 1, because it's written in the reverse order from what it was before. Sorry, guys. My H is over here. Let me highlight what I'm doing. Here's my H. Here's my K. Negative 2, 1. Then I'm adding the negative 3/2 to my 1 and getting a negative 1/2. Which was the question. One more idea here is this reflective property of a parabola, which is cool. This ties into a calculus concept, and you'll learn how to find the tangent line next year. And you'll be able to, if you recall this property here, compare results, and of course you will get the same equation. But we're going to look at how do we find a tangent line to a curve, right? And a tangent line requires a point and a slope. So if you have a true tangent and you're only looking at a curve, it's hard to come up with that slope because slope is developed using 2 points. And when you're tangent to a curve, that means you're touching at exactly one moment. So it's helpful to figure out, well, what is this point? What is the y-intercept? The property that allows us, because of these things being true, so I'll read it. It says, the tangent line to a parabola at a point P makes equal angles with the following 2 lines. The line passing through point P and the focus and the axis of the parabola. So if this axis is shifted, right, it's a little bit of a different story, but we are taking a look at coming up with that tangent line. So because those angles are the same, we are creating an isosceles triangle. And therefore the other things that are the same that can be helpful are the distances here and here. They are also congruent because it's an isosceles, all right? So we will always have these 2 points, the focus and point P. So we could always come up with that distance. And we will always have an understanding of how far away this is as a relationship or an expression. But once we know exactly what this distance is, we can set it equal to this expression that we'll come up with and know exactly where this point is. When we have this point, when we have this point, then we can come up with our slope, then we can come up with our line. Okay? So find the equation of the tangent line to the parabola given by x squared equaling 2y. And the point 3, 9/2. Okay, so I'm just going to do a quick sketch of this. So in my head, I'm thinking of x squared equaling 2y as y equaling 1/2 x squared. So it's just a parabola. It's a little bit wider, but it goes through the origin. But my vertex is at the origin. I have point P, 3, 9/2, we'll call it there. A tangent line, kind of run like that. It's not super straight, but you guys get the idea. The focus, which we haven't found yet, we will, is going to go right around here. So we know that this angle and this angle are the same, and therefore we can use the fact that here and here are the same distances. Okay, so I just got the visual, not that you have to every single time, but let's take a look at finding some of these key points, like the focus. And in order to get to the focus, we want to put it in standard form. So we can acknowledge that this is the same as having x minus h quantity squared equaling 4p times y minus k. Right, so the h and the k must be 0, 0. So our vertex is 0, 0, which we knew just through graphing it by itself. We know that the p, if we have this coefficient of a 2 here, then the p must be a 1/2. So our equation really is x minus 0 squared equals 4 times 1/2 times y minus k. So if our p is 1/2, then our focus, which is a vertical shift, is 0, 1/2. Alrighty? So then we can come up with, well, what's that distance between point P and the focus point? Because that distance is the same as the distance between our y-intercept here and our focus. Right? So if we call this D1 and call this D2, well, D1 is the distance formula between these points, square root of x minus x1 minus x2, whatever. So 3 minus 0 squared plus 9/2 minus 1/2 squared. Right? That's what D1 is going to be equal to. Find that in a second. D2 is equal to, it's helpful to get the picture because this distance, right, is positive. My focus is definitely above this. This is the y-intercept. We can call this B. So the distance between the focus and the y-intercept is 1/2 minus B, right? Top minus bottom. Does that make sense? The 1/2 minus B portion? If this graph was flipped for a different example, and the y-intercept ended up for the tangent line ended up being above, I would have to do B minus whatever that focus was, because it's important that we get it to be a positive number. So D1 happens to be a nice round, easy number. 9 plus 9/2 minus 1/2 is 8/2 or 4. 4 squared is 16, so 9 plus 16, 25. Square root 25, we get 5. So 1/2 minus B is also 5. They're the same thing. So B is equal to 4.5 or 9/2. So that's the B, which goes directly into y equals mx plus b. How do I get the m? Right, my whole goal is to come up with the tangent line, y equals mx plus b. So we've got our b of a negative 9/2. I'm sorry, guys. We just need our m. How do we figure out what the m is, actually? Yeah, you can just do the slope formula. We have 2 points now. We have the original 3 9/2 given, and we have the y-intercept 0, negative 9/2. Right? So if we do m, or the other way to do it, we have almost all of our equation. We could take the point and plug it in for the x and the y and solve for m in the equation the same way. So that's up to you. But we have 2 points, so we could say, well, what's 9/2 minus negative 9/2 over 3 minus 0, right? So that goes plus positive, so that ends up being 9 over 3, or 3. So our answer is y equals 3x minus 9/2.